Now that we've configured OSPF, let's learn some commands that we can use to verify what we have just done. And the first and probably the best command to do this is the show IP protocols command that is typed in the privilege mode of the router. And this command will display information about all the routing protocols that are running on the router. In our case, if we have only OSPF, that's what we're going to display. The next command we can use is to show IP route, which shows the routing table of the router. And in the routing table, again, I'm reminding that it is only the best paths to all the destinations that the router can see. Not all the possible paths, but only the best paths to those destinations. The next command we can use to verify is the show IP OSPF neighbor, which displays us the neighbor table of the router. And in this neighbor table, we have a list of all directly connected neighbors. And we can use also the show running config, or show run for short, command to basically display all the running configuration of the router, or the configuration that the router is currently using, which is probably the best way to view any kind of configuration, or to verify any kind of configuration. But now let's see an example here. If we type the show IP protocols command on the router A that we just configured, the output will be something similar. It says that the routing protocol is OSPF 5. That means that the routing protocol is OSPF and the process ID is 5. Then it will say something like this: the router ID is 192.168.1.1. I haven't mentioned that before, but because link state protocols communicate with every router within the entire topology, there had to be some way to differentiate themselves. So just like, you know, your names or my name, and just like the phone numbers that we have, every single person has a unique name or unique phone number that separates him from the rest of the people, and that's how you identify him. Well, in the same sense, the OSPF uses the router ID to differentiate himself, or to make himself a unique within all the other routers on the network. But we'll discuss more about the router ID in the advanced video of the OSPF. Then the next thing that we'll deduct from this command is that says that this router belongs to only one area, and this area is a normal area. In our case, is the area 0, and it will tell us that router A has 3 networks that he's advertising to the world, and the networks are 12.12.12.0, which belongs to area 0, the 13.13.13.0, which also belongs to area 0, and finally the 192.168.1.0, which was the local area network, also belongs to area 0. The next thing is to tell us that this router, or router A, has 2 neighbors that he's exchanging information with. The 2 neighbors are the 192.168.3.1, which was router C. The administrative distance of this neighbor is 110, which is the default administrative distance for OSPF. And the last update we have received from that neighbor is 18 minutes and 37 seconds ago. And the next neighbor is the 192.168.2.1 router, which is the router B, and it has also the same administrative distance, and we haven't received an update or LSA from that router in 18 minutes and 37 seconds. And in the last, we can see that the default administrative distance of OSPF is 110, but we already saw that. So that's it. That's pretty much all you need to know to configure basic OSPF with no advanced things on it, but it will be more than enough to run and to route between your different networks and your different routers. And just to summarize what we just did, or what we just talked about, is that we said that OSPF is a link state protocol which enables him to talk to everybody within the network, and it provides us with a 100% loop-free topology. But because he was a link state protocol, he needed to have some hierarchical design on the network, and he had to include different areas in order for him to be able to operate properly. And it also provides with a fast convergence, because being a link state protocol and having the different areas, and as a typical link state protocol, the OSPF gives us the ability to perform classless routing. And the command that we used to configure OSPF was the router OSPF and then the process ID, which can be different for every OSPF implementation. And then in the end, we use the network command in order to advertise all our networks that we possess to our neighbors. And the syntax was that the network and then the network that you want to advertise with the wildcard mask, and then in the area that you want this network to be. And that's it. That's all you need to know for the OSPF. And all the details, all the advanced things that OSPF is capable of will be seen in the next video, which is the second part of the OSPF.